So what we're going to talk about today is exponential equations. And exponential equations means there's an x in the exponent. And what do all equations have?
Numbers.
Numbers, yeah. What? An equal sign. Good, okay. So we're going to be dealing with things that have an x in the exponent and an equal sign. Does anybody know what x would have to be to make this true? 3 to the what is 9? 2. Good. So x has to be 2 here. Now this one was really easy for you guys to solve. But what we're going to look at today is things like, what about if you had something like this? You guys think we could just guess and check?
Yeah.
I mean, maybe eventually be long though, and we won't just know it. So what we're going to look at today is stuff that looks like this, and you guys are going to be able to solve it. The big thing though is that we understand what our bases are to certain powers. So let's just go through some things real quick. What is 2 squared? 4. Good. What about 2 cubed? 8. Good. How about 3 squared? Oh, sorry, 3 squared. Good. 3 squared is 9. What about 3 cubed? Does anybody know that one?
27.
Oh, 27. Nice job. Okay. 4 squared is 16. Does anybody know what 4 cubed is? 64. Good job. That's okay. All right. Now, so if you have a calculator, or I think even your phones will be able to do like an exponent, like just solving it out. So you're going to see a lot of this stuff kind of come up. Once we have an exponential equation, right? We talked about the variables in the exponent. What we're going to be using the idea of is this property, okay? Where these are like the bases. So what it's saying is, if the two big numbers, the two bases are the same, what we can do is just take the exponents and set them equal to each other. Okay? So if we have two things here on the screen, the bases are the same. Okay, like my first little example. See how they're both like 7? Okay, so if the bases are both the same, that means what we can do is take the exponents and just set the exponents equal to each other. Now, how would you guys solve this equation? Was that okay? Good, exactly. Nice job. Good job. All right, that works. So then let's see, we have 1 equals 3x minus 2x is just 2x. Good. Yep. And then what else would we have to do? Add 2 over. Good job. Nice. So x equals 3. Perfect. If you wanted to put this back in to check and make sure you would get the same thing on both sides, you can. You don't have to do it though. Okay. Now, that's pretty easy. Right. The next part is what you guys are going to be dealing with a lot more. If the bases are different. Okay. So, meaning, if I look at my two big numbers for this next example, we got a 3 and we got a 27. Right? What we're going to do is figure out how to make them the same, right? But we can only use exponents, right? This is a big thing, we can only make them smaller, not bigger. Okay? So the idea behind this is, as it gets easier, if you guys use a smaller number to kind of help you along. So if you have 3 here, what we want to think is, can I use 3 to some exponent to get 27? So if you guys think about your list, okay, 3 squared was 9. What's 3 cubed? 27. Okay. So we're going to use this idea. Your goal, guys, is to get the bases to be the same. So instead of 27, instead of that, I know that 3 cubed is 27. So instead of the 27, I'm going to get rid of it and make it 3 cubed instead. Yep, good question, Gab. Right, whatever's up here, guys, we're going to bring it down. Right, and it's going to end up being multiplied by the new x. So see, on the other side, I already have a 3. Now are your bases the same? Hopefully, yeah. So once the bases are the same, life is good. This is your goal, to get those two numbers to be the same. We're going to take the exponents and set just those equals to each other. So it's going to look like this. 2x minus 1 equals Now on this side, we had to remember to bring that x down, but now we have 3 times x, which is 3x. Okay? So when you guys solve this like an equation, what do you think? Minus 2x. Good job. X equals -1. Perfect. The hardest part is the first step. It's figuring out like what do you need to raise it to get the same number. But if you use a smaller one for some help, it's usually works pretty nice. Okay. Right. Let's try another one here. Okay. So do we have the same bases or different bases? Good, different. So our goal is to get those numbers to be the same. So use the smaller one for help. Right? You want to think, is 5 to some exponent and give me 25? 5 squared, awesome. So we're going to get rid of the 25 and we're going to put in 5 squared in its spot. So we'll put this 5 squared. Take down your exponent, that's you. That was already there. And this side we're going to have to change. Right. Now are these the same? Yep, life is good. So once you guys have the same base, we're going to take the exponent. Right, 7 equals, so 3x minus 8 equals, make sure you multiply here, so 2 times 2x is 4x, yep. So when we solve our equation, good job, yeah, it's -8, good work. Are you guys okay with solving equations? 5. We're going to, Erin, part of this is a good question, is using the property, the 5 really just like goes away. We're using this property here, that if you can make the 2 big numbers the same, like how we made them both 5s, that then you can just take the exponents instead of equal. You don't use the b's anymore, you don't use the big numbers. Kind of like a weird thing, they just go away. But by making them the same, that's why they do that. If you keep them different, you can't do that. What happened? Somebody a long time ago really had a lot of time on their hands and were pretty smart. All right, let's try this one next. This one's a little bit tougher for you guys. Let's see. Well, all right, so usually we use the smaller one, right, to kind of help us. But if we think, can 9 to some exponent, like a 9 squared, can that give you 27? No, 9 squared gives you what? 81, all right. And 9 to the first is just 9. So do we have something, if I use 9, that can make it 20? Oh, you guys are so smart. Good job. So sometimes we might not just be able to do one of them. Sometimes we might have to make them both smaller. But I like what you guys were saying, right? That doesn't work. Well, you said 3s, right? What 3 to the what gives me 9? Close. 9 squared. Good. So 3 squared gives you 9. Seb, what does 3 cubed give you? 27. Good. So see how we can take the 9 and the 27, but we can use the same base of 3 now, right? But you have to know your exponents to use. All using exponents. So instead of the 9, we're going to get rid of that, and then we're going to put a 3 squared in the spot. All right, don't forget to bring down your other exponent. Instead of the 27, we're going to get rid of that one and make it 3 cubed. Okay, same thing. Don't forget about the exponent. We got to bring it down. Right. Once our bases are the same, we're going to take the 2 exponents and set them equal to each other. So you guys can take this in 1 step, in 2 steps, whatever you want. But be really careful. See how you have a 2 that needs to be multiplied through this whole thing? Watch your distribution. Okay, make sure you remember to bring it through to all of them. So if you distribute it through, it becomes 2x plus 2 equals 3x. Now when we solve it, minus our 2x. Right, so 2 should equal. That was great, you guys recognized that you had to use 3 there. Good work. Let's see if you can do some of these on your own here. We will not be using the fractions in this class, right? That's more of a region thing. So why don't you guys try 5 and 6? See if you can do that one. Anybody wants to come up and put it up? Check it out with your neighbor. You guys can talk about it. I'll walk around and get some help if you need it. Use the smaller one for some help. See if that will work. If you guys get a fraction, it's okay. Okay, you can only make them small, you're not going to with the right idea. Well, it would make them the same, but you can't make them bigger, so you only make them smaller. So use this idea, put over here. So instead, make that 8 into 2. Have to change this side instead. Okay, so you're going here. So if you want, you can only make them smaller. So here's the 8. So just 2, because you have a 2 over here, 2 to something to the 8. Just have to do it like this. So 2 squared is 4, 2 cubed is 10 or something. Yeah. Good. So what we're going to do is instead of that 8, we're going to use 2 cubed instead. Anybody want to put it up there for us? And you can multiply this if you want to, like in one piece. There you go. So now you saw that. You guys should be getting a fraction of some sort. Good. Take her big. I'll put it up on the board. Thanks, Aaron, that one where it is. Okay, where that's the no. Have you guys got? I think it's a fraction. when you separate, you need to get rid of them.
I know. Thank you.
If you guys got 2/11 for 5, okay, go on to 6. No, do it though. Some people did not get that, Aaron. Keep going. Throw all the lovely work up there.
Except it was PHA.
I know, but that's do you know what I'm sure? No. Okay. Well, we're gonna do now.
I forgot the really crappy like water too, so. Great thing that she could have.
What did I write?
Okay, so right over here, right now. Now this guy is already has pictures, so it's easy. But if you have the same thing on the bottom, you're going to put them equal to each other. So once you do it, so you guys are going to take that too. Right there. So it's equal. So here you got 3 times the correct. What that would be.
Oh, that's so bad.
Okay, good.
I'm so real out of time.
Yeah. Very nice. Thanks, girls. That looks great for 5 and 6. If you guys got 5 and 6 tonight,
looks better.
try number 9. Okay, that'll be the last one. Try number 9.
And can you do number 9?
I just like him. What that has to do.
I'm gonna look it up. Oh, there's already one. Oh, we were doing that?
Oh, yeah.
No, we're having issues.
You're having issues? Yeah. All right, guys, for your last question here, we have a 9 and we got a 3. Can we make a 9 using a 3? Yeah, 3 to the what? Second. 3 squared. Great job. 3 to the second. Nice. Okay, so don't forget, take that exponent, bring it through. The other one's already a 3, so we don't have to do anything. Just be very careful. Take this 2 and bring it through to both parts, okay? When you guys do your multiplication, make sure you distribute. So 2 times x squared is that? 2x squared. Good. Plus 2 times x is 3 equals 4. Alright. Now this one's pretty tough. Is this like the one that you guys have been doing, or does it look a little different? It's different because it has that x squared. What did you guys have to get something equal to when x squared was your highest exponent? 0. Nice job, Jeff. Yeah, alright. Wow. You go. Good. So we gotta get it equal to 0 first. So I'm gonna move the 4 over. Okay. I'm gonna do one thing before I start my double bubble stuff though. When you guys went to factor, I didn't do you guys anything this hard tonight. But when you guys go to factor, does anybody remember what you look for first? Starts with a G. Good. GCF. Do we have a GCF here between a 2 and a 4? 2. Good. 2 goes into all those. So the thing I'm going to do first to make my life easier is take out your GCF. Okay. So we divide all of these by 2. Right. -4 divided by 2 is -2. Okay. It makes it much easier because then you guys have a 1 in front. So when you double bubble this, does anybody remember how to double bubble it?
Yeah, both and x.
X and X, good. Do we have factors of 2 that make a 1?
1.
Well, 2 and 1, good. Which one's got to be a plus so if you want a positive one? Good, Aaron, the bigger one. Good job, the 2. Nice. All right, what's your last step?
7 equals to 0.
Yep, 7 equals to 0. Good job. So over here, can 2 equal 0? Does that make sense? No. Right? X plus 2 equals 0. Alright, so to solve this one, we have the -2. So x equals -2. So if you set this one to 0, how would you guys solve for x? Add the 1. Good job. So x equals 1. The stuff I gave you guys doesn't have x squared, but I mean, you might get something like that on the SAT. Anybody doing that stuff too?
I'm not taking it.
You're not taking them? It's alright.